Welcome to our mathematics class, Introduction to Trigonometry. Our prerequisites for this topic are: we need to have a knowledge and understanding of the order of operations, knowledge and understanding of fractions, knowledge and understanding of exponents, knowledge and understanding of equations. Our expected background for us to be able to understand this topic is we have passed grade 9 mathematics. You are now in grade 10 or grade 11 or grade 12. You have the knowledge of Pythagoras theorem and its application. What will you learn from this series of lessons? You will be reminded of Pythagoras theorem application. You will be introduced to trigonometric functions, e.g. sine function, cosine function, tangent function, cotangent function, secant function, and cosecant function. You'll be introduced also to trigonometric identities. You'll be introduced to trigonometric equations. You'll be introduced to deriving and applying a sine and a cosine rule. You'll be introduced to reduction formulae. And finally, you'll be introduced to trigonometric graphs. Which base are we sitting on, or what do we know already? From grade 9, we were introduced to a mathematical tool called Pythagoras theorem. It helped us to calculate or determine the length of one side of a triangle, provided a given triangle is a right-angled triangle, provided the given triangle has two known sides. Now, Pythagoras theorem states in a right-angled triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. That is, c squared equals to a squared plus b squared. Now, to verify that, given a triangle with the given sides, we say bc squared plus ac squared equals to ab squared, or we can use the representative letters of each side in this manner, and then we substitute the values and we simplify the exponents, and finally we get that the right hand side equals to the left hand side, which now verifies that this Pythagoras theorem is the truth or states what is true. Then again we look at another example with triangle PQR with its representative sides, small p, small q, small r, and then we apply the Pythagoras theorem and then to verify. So here we put the representative sides of the triangle and then we substitute their values, and finally we simplify and we get that the left hand side and the right hand side are equal. So indeed, Pythagoras theorem stands for the right-angled triangle. Now let us look at examples on what you did in grade 9 to calculate the sides, one side of a triangle when you are provided with two sides. So here's a triangle with one unknown, which is the hypotenuse side. So applying the theorem, then when we substitute the values, we find that side C squared equals to 100, and then that means that C is the square root of 100, and that gives us to say C is 10 units. Example 2, we look at the side. We are requested to find the side PR, which is represented by the letter small q, and then applying the formula, transposing to make PR the subject of the formula, and substituting the representative sides, and that gives us 13 squared minus 5 squared when we substitute the values, and that finally gives us q squared equals to 144, and finally to say q is 12 units. And this is the application of what we learned in grade 9 of Pythagoras theorem. But we have a problem, or we have a challenge. Pythagoras theorem is limited to a right angled triangle, provided we are given two known sides and we are asked to determine the other side. So what if now we are given a right angle with one extra known angle and one known side? How will we go about? So here's a triangle, we have one known side, we're given a right angle, we're given an extra angle 35 degrees. Now the other two sides, x and y, we do not know, and we are asked to calculate them. Now, with Pythagoras theorem, we are now stuck. We can't move any further. Now, we now get what we call the entrance of trigonometry to bring us solutions. Now, with trigonometry entering, we can say trigonometry comes in very handy by bringing with him more tools and techniques to the solutioning of all types of triangles. Now, in this case, what do we need to achieve? Our intention is to solution all sorts of triangles. And what do I mean by this? I mean that we should be able to find the values of unknown side or unknown sides of a triangle and unknown angles in any type of a triangle. We should be able to solution our triangles irrespective of which triangle we are given, whether it's a right angled triangle, whether it's an acute angled triangle, whether it's an obtuse angled triangle. We should be able to find the solutions of what we are requested to determine. An example is given below, where you're given a triangle with unknown angles and one unknown, or we are given a right angled triangle. We should still be able to solve any kind of a triangle. Now, our solution that we have come with, which is trigonometry, tells us there's a mathematical relationship between the angles and the sides of a triangle. And that mathematical relationship is based on what is called trigonometric functions. Now, let us have a look at what the word trigonometry. Trigonometry has the letter tri, which means 3, has in it has the letters gon, which means angles or sides. It has what we call metric, which means measurement. So in short, trigonometry deals with measurement of angles and sides of triangles. Now, having to apply what we have learned, that there's a mathematical relationship between the angles and sides of a triangle, we now want to apply one trigonometric function, which is called sine. Now, given the right angle triangle, we are going to see how we can now apply this relationship of the angles and the sides. And now there it's given to us that if you know angle alpha, and you know AB, and you know OA, there's a relationship that is given by sine alpha equals to AB over OA. And in the same manner, if you know angle beta, and you know OB, and you know OA, you would know that sine beta equals to OB over OA, right? So you can make AB or OB the subject of the formula in one of the equations as provided, and OA can also be made the subject of the formula. I would like to make you aware that in this moment, you don't need to scratch your head to try and understand where this comes from. This will be dealt in detail in the next chapter that has to deal with introduction of trigonometric functions. Now we can continue and do the same for the cosine function. Given the right angle triangle and we are given the angles alpha and beta, you can be able to establish a relationship to say cos alpha equals to OB over OA, cos beta equals to AB over OA, and in the same manner you can make OB and AB the subject of the formula, and or OA can also be made the subject of the formula. So in this case, you don't need to apply the same equations at the same time. You just choose one. Now let us look at the example. We are asked to determine the length of AB given the triangle AOB, where OA is 5 units, alpha is 53.1 degrees. So we have a right angle triangle where OA is known and angle alpha is known. So in this case now, we have alpha known, we have OA known, and AB is unknown. So we can be able to use this equation, make AB the subject of the formula, and now on the right you will have what is known, and then you may substitute, and it helps us to find AB to be 4 units. And in the same manner, we can apply trigonometric function cosine or sine again to find OB. Now, again, given the same triangle, we can be in a position now to say cos alpha equals to OB over OA, where now OB can be made the subject of the formula. And then on the right now you have what is known, substitute the values, and then we find that OB is 3 units. So now, in short, we have our summary to say there's a mathematical relationship between the angles and the sides of a triangle, and that relationship is based on what's called trigonometric functions. Now, in this case now, we have gone beyond the first hurdle to say, given one known side and one extra known angle in a right angle triangle, we can determine the value of the other 2 sides and the remaining angle of a right angle triangle. Now let us move further from right angled triangles. Now, if a triangle is an obtuse angle or an acute angle triangle, or any other type of a triangle beside the right angle triangle, we can calculate the known sides or angles using sine or cosine rule from the trigonometric toolbox. For instance, you can be given an obtuse angled triangle with 2 known angles and one unknown and one known side. The other 2 sides are known and the remaining angle is unknown. So in this case, we say we can apply what is called the sine rule to determine the other 2 unknown sides. In the same manner, again, we can be given a triangle with 2 known sides and 1 known angle. And this triangle is not a right angle triangle. We can use what is called the cosine rule to determine the side QR and the remaining 2 other angles of a triangle. Now, at this moment, I'm not expecting you to understand what we are saying here. This is more to say we are introducing a new tool to you called trigonometry, which is now able to do far beyond what Pythagoras' theorem can do. I look forward to meeting you in the next series of lessons, where now we will begin with introducing trigonometric functions, and we will go beyond to understand how can we go into more triangles which are not right angle triangles to apply the sine rule and the cosine rule. I look forward to seeing you in the next lesson, and please avail yourself so that you may understand more.